Hello, hello. Am I audible, visible, guys? Are we live? Hi, everyone. Are we live? Hi, everyone. Good evening, everyone. Are we live? A very good evening to all of you. I hope you all are doing well. एकदम बढ़िया, एकदम मस्त, एकदम ढिंचाक. A very good evening, and I'm here with another session, B2A series, Basics to Advanced for NSEJS Junior Science Olympiad aspirants, or I can say any science lover who is in class 8th, 9th or 10th want to learn more of a science beyond the school curriculum. This series is perfect to satiate that curiosity of science. Good evening, everyone. Hi, Tejas. Hi, Yash. Good evening, everyone. I hope I am audible and visible. Yes, let me know. Am I audible, visible? Ground state is the most stable state where the electron is most stable, its energy is lowest, it is feeling the maximum attraction from the nucleus. So I hope you got your doubt, Yash. Okay, guys, so I am audible and visible. So in today's session, we are going to learn very interesting phenomena, very interesting topic for which our Albert Einstein got the Nobel Prize. Many students, they feel that Einstein got the Nobel Prize in physics for theory of relativity, but that is not true. But he got the Nobel Prize because he explained the cause, the phenomena of photoelectric effect. So in today's session, we are going to study what is photoelectric effect and how our very own Einstein G explained this phenomena using Planck's quantum theory, right? So those who know Planck's quantum theory, please let me know in the chat box quickly. Yo, if you know the Planck's quantum theory, write yo in the chat box. And if you don't know what is Max Planck quantum theory, the theory about light, the theory about electromagnetic radiations, if you don't know that theory, write no in the chat box. Okay, so yo or no, if you know what did Planck said about the light, this light, the electromagnetic radiation. If you know the Planck's quantum theory, write yo. If you don't know the theory, write no. And if you're writing no, please do check out the last week's session of the same series where I told what is Max Planck quantum theory, what is the concept of quantization, and how, and like using what basis our Planck explained the nature of light. Yes. Okay, so the $1,000,000 question is, I can see those who are active in the chat box. What is the $1,000,000 question? Light, this visible light, is it wave or a particle? Our light is a wave or a particle? This is the $1,000,000 question, guys, right? Light that you can see, is it a wave or a particle? Yes, your views on the same, guys. What do you think? What is light? Is it a particle? Does it show a particle nature or it has a wave nature? Yes. What it is? Okay. Both. So let me put some light on this phenomena. Right? So Maxwell gave EM theory, right? Electromagnetic radiations theory, Maxwell's EM theory, very famous theory. And in his theory, Maxwell considered the light, electromagnetic radiation as wave. So according to Maxwell, light has a wave nature, continuous like a wave, right? But later on, Maxwell EM theory failed and Maxwell could not explain the phenomena of photoelectric effect using his Maxwell's EM wave theory, right? Then because of the failure of Maxwell, we have another theory given by Planck that I talked about in the last session, Planck's quantum theory. So according to Planck said exactly the opposite, that light has particle nature, right? So it has quantas, the packets of energy. It is discontinuous in nature, right? So according to Maxwell, light has a wave nature, and according to Planck, light has a particle nature, right? Now, who is right about the nature of light? Yes. Yes, please. So light has a dual nature. It has a dual nature. It behaves like both, right? It has a particle nature as well as the wave nature. So when your light interacts with a macroscopic object, a bigger object like lens, like prism, its wave nature dominates. So when your light hits the building, the macroscopic object, its wave nature, it behaves like a wave, right? Light is very smart. Light knows how to interact with whom, right? The interaction of light depends upon with whom the light is interacting. So with macroscopic objects, it interacts as a wave, showing the various phenomena, diffraction, friction, interference, right? Whereas when your light interacts with a microscopic particle like electron and atom, its particle nature dominates, right? It behaves like a particle. It has quantas or packets of energy. It has photons, right? So this is true when it interacts with macroscopic objects, and this is true when light interacts with the microscopic particles. So basically our light has a dual nature, right? Yes. So light has a dual nature. It has both the behavior, guys. Now let us see how photoelectric effect is explained by the nature of light and how Einstein explained it, which Maxwell couldn't explain, right? Using the wave nature of light. Now, let's understand what is photoelectric effect. So, photoelectric effect was discovered by the famous scientist, as you can see on your screen, Henrik Rudolf Hertz. I hope you remember the unit of frequency, right? The number of waves passing through a point in 1 second, frequency of a wave, that is Hertz, Hz. The scientist, right? From where the unit is there. So it was discovered by this phenomena of photoelectric effect was discovered by our scientist Hertz. So what is photoelectric effect? So it has two terms. One is photo. Photo represent light. Electric, electrons, current, right? So it has something to do with light and electricity. So basically what is photoelectric effect? So this is your metal. Metal has atom, atom has electrons. So when a light, electromagnetic radiation falls or incidence on the surface of metal and there is an ejection of electrons from metal surface, this phenomena is known as photoelectric effect. Photo, light falls on a metal and electrons get ejected out. They comes out of the metal surface. And if these electrons has kinetic energy, if they start moving, charge in motion is current. Got it, guys? Yes. Mentality monster, please connect me separately on Telegram for the RM batch. So, photoelectric effect. What is photoelectric effect? When electromagnetic radiation falls on the surface of metal, the emission of electrons from the surface of metal on the incidence of electromagnetic radiation, light is also electromagnetic radiation, this phenomena is known as PEE, photoelectric effect. Got it? Yes, so this is photoelectric effect. Yep. Now, there is a condition to this photoelectric effect, right? There's a condition. You can see the animation here, the photoelectric effect. So you can see there's this photosensitive plate and the light is falling on this plate, a metal plate, and there is the ejection of electron. Electrons are moving in this tube. This is photoelectric effect showing in this animation. Please see the electrons are moving. They just come out of the metal surface, right? Now, guys, what is the condition? There is a very important condition. Suppose I have a metal, right? And I want to have photoelectric effect. I want that electrons should come out of the metal surface. So guys, try to understand, if electrons are coming out of metal surface, so metal has atom, atom has electrons, right? So for an electron to come out of atom, it needs energy. That we call ionization energy. There's a metal, there's an atom. you want to take out electron from that atom. So you are supposed to supply some energy, minimum energy, that is known as ionization energy. So basically, if I am incidenting radiation on the metal surface, that means I am supplying energy to the atoms of the metal. And if that energy is sufficient to remove the electron from metal atom, the electrons will come out. So basically this is happening, right? Yes, you are supplying energy to the metal in the form of radiation, and if the energy in that radiation is sufficient to take electron out of that metal atom, the electrons will come out, the emission will take place, and that is what we call photoelectric effect, right? So now here the important condition is, what is the condition? That the energy in this radiation, that we write h nu, that should be sufficient to take out the electron from this metal, right? Suppose I have this metal and the energy required to remove the electron from metal atom is, let's say, 10 joule, right? So to take out electron from the metal atom, the minimum requirement of energy is 8 joule. This is the threshold energy. Threshold means the barrier, the minimum energy required to take out the electron. And I am giving the light which has 8 joules energy. The energy in this radiation is 8 joule, right? The quanta, the packet, because I hope you remember, according to Planck theory, this radiation has a small packets of energy, and the packet of energy, the amount of energy in each packet depends upon the frequency. Those who don't know, please check out the last session, E is equal to h nu, right? So suppose the energy in this radiation is 8 joules. Can the electrons be ejected out with this light from this metal surface? So the requirement of metal is, dude, I want 10 joules energy minimum. That's the deal. If you want to take out the electron from me, just supply me energy at least 10 joules. Now this radiation which I am falling on the surface of metal is having 8 joule energy. So as per the deal, this will not work, right? Minimum requirement is 10 joules and I am giving 8 joules. No ejection of electron, no photoelectric effect, metal will not give away its electron, right? So no photoelectric effect. Okay, so let's say I am giving 9 joule, will it? Suppose I am giving 9 joule of energy now. Again, no. Metals, the minimum required energy to take out the electron from my atom is 10 joules. So no 9 joule. 9.8? No. 9.9? No. Suppose I am now giving the energy. The radiation has energy 10 joule. Will the electron come out? Yes, because the minimum requirement is 10 joules. That is the threshold energy. The minimum energy required to take out the electron from this particular metal. Yes, the electron will come out and the photoelectric emission will happen. The electron will come out of the metal surface. Now suppose I am incidenting a radiation which has 12 joules of energy. What will happen, guys? Yes, what will happen? If I am supplying 12 joules of energy, what will happen? Puneet, I will revert you on the Telegram. Don't spam here, bache, right? I will revert you on the Telegram. So, see guys, this is what happened. So, whenever you got the opportunity to be a part of like the elite batches of Vedantu, just like RMO or Abhimanyu, please do not, just take that opportunity as such for granted, because later on you will regret and then we can't do anything, because sincerity and dedication is the topmost priority for us. If any student we take in our elite, super elite batches, we are not taking any fees, no charges for our Abhimanyu RM program. But what we want is sincerity from you. If you are not sincere, dedicated enough about the batch, we have so many students who want to be a part of this batch, right? So please value the batches that we are providing free. Many times you guys consider that if we are providing something free, that is like for granted. Okay, it is for free, it is always there. No, that is not the deal, right? So the fees that we take for our super elite batches producing result is your dedication and sincerity for the batch. That is the requirement. If you don't fulfill that requirement, I'm really very sorry to tell you guys, that's that is not something we are offering you then. Yes. So please value whatever, like if you get a chance, if you get opportunity to be a part of any such batch, value that, otherwise you will regret, and we in future we can't do anything because that is our condition, right? Okay guys, so let's get back to our photoelectric effect. So if the requirement is of 10 joule and I am providing 12 joule, what will happen? Yes, what will happen guys? What will happen? What will happen? To take out the electron from metal, 10 joule energy is required and I'm giving extra. I'm giving 12 joule. What will happen? Just use the common sense, guys. So, ma'am, it will come out using the 10 joules, but that extra 2 joules, energy is conserved now, guys. So, where that extra 2 joules will go? Yes, where that will go? Sure, Utkarsh. Where that will go? Man, that can be converted into the maximum kinetic energy of that ejected electron, right? So by using 10 joules, the electron will come out, and we call that electron photoelectron, the electron that come out of the metal surface. So the 2 joule, the extra 2 joule can be converted into its maximum kinetic energy. Now your electron will come out and it will start moving, and that can have a maximum kinetic energy of 2 joules. So these moving electrons, the charge in motion, guys, what we call it is a photoelectric current, right? So this is a photoelectric current. So now here I'm going to put forward a point that to eject an electron from metal surface, there is one requirement. What is that requirement? That the energy of the radiation should be more than the threshold energy of the metal, right? So there is a requirement, minimum energy requirement for every metal, and that is different for different metals, because for every metal we have a different arrangement of electrons and the ionization energies are different, right? So different metals have different threshold energies. Until or unless that condition is not being fulfilled by the incident radiation, right, the electrons will not come out, the photoelectric phenomena will not happen. Got it? Yes. So what is threshold energy? Let me write it by E naught. What is threshold energy? The minimum energy required to remove an electron from metal surface, or the minimum energy required to show photoelectric effect. The minimum energy requirement for the incident radiation, the radiation that we are falling on the metal surface. Yes, this is threshold energy. We call it threshold energy, yes. Here, right? And you know energy by Planck's quantum theory. Energy is h nu naught. The energy of the radiation, the energy of one packet, one quanta of radiation is equal to h. That is Planck's constant, and nu is the frequency of radiation. So nu naught, what is nu naught? That is threshold energy, frequency. Threshold frequency, right? So to show photoelectric effect, the condition that the radiation that we are falling on the metal surface, the frequency of that radiation should be more than the threshold, equal to or more than the threshold frequency, right? That means what is the condition here, guys? That to show photoelectric effect, ma'am, the radiation, the energy of incident radiation, see, mu is the energy of incident radiation, that should be greater than or equal to mu naught. That is the threshold frequency, the minimum frequency required to show photoelectric effect. So every metal has a threshold frequency that I want at least the radiation of this frequency to show photoelectric effect, right? So what is the condition? That the incident frequency, the frequency of light that is falling on the metal surface, should be equal to or greater than the threshold frequency of the metal, and mu naught depends upon the metal. Yes, fact motion I just explained. If you give extra energy, the extra additional energy will get converted into the kinetic energy, the maximum kinetic energy of that electron which is moving, right? Yes. So guys, this is the photoelectric effect. You can read. Yes. So if the incident frequency is, suppose the radiation that you are incidenting on the metal surface, so if the incident frequency is less than the threshold frequency of the metal, no photoelectric effect, no ejection of electron, no photoelectric effect, right? Now, if the incident frequency is equal to the threshold frequency of the metal, then electron will get ejected, electron will come out of the metal surface, right? And in case incident frequency is more than the requirement of threshold frequency, then what will happen, guys? Then ma'am, electron will come out with maximum kinetic energy equal to mu incident minus mu naught, right? The difference, requirement is 10 joule, you gave 12 joules, so that 2 joule can get converted into the maximum. The maximum kinetic energy that can electron have is 2 joule. It can be less than that because there is a dissipation or wastage of energy, but not more than 2 joule, right? Yes, got it? Yo. So this is photoelectric effect. Now you will ask me how Einstein explained the photoelectric effect. So Einstein explained this phenomena, these observation of photoelectric effect on the basis of Planck's quantum theory, where light is considered as discontinuous particle nature. So, right, according to Planck, the light has a particle nature. It has quantas, it has a packet of energy. And the packet of energy is equal to h nu, right? Each packet has equal energy. And there is n number of packets. N can be 1, 2, 3, 4, 5, 6, 7, 8. It cannot be fractional. The packets in a light cannot be fractional. It can be 1, 2, 3, 4, 5, 6. So your light has small packets of energy that we call quanta. And each packet of a particular radiation has equal energy. So all these quantas belonging to the same radiation, they have same energy. So the energy in each packet is same. And the energy of the packet depends upon the frequency of the radiation, right? So E of packet, energy of one quanta. This is what Planck said. So the light that is falling on you, that has small packets of energy, photons, and the energy of that photon depends upon the frequency of this wave or radiation, right? Yes, got it? Indirectly, yes, Tejas. Done? The Planck quantum theory can be explained by using this, but not the photoelectric effect. Okay, guys? Done? Okay, fine. Now how Einstein used this theory, quantization, to explain the photoelectric effect. Now listen everyone, right? According to Einstein, you are falling radiation on the metal surface and that radiation has small packet of energy, right? And using that energy, the electrons of metal atom, they are coming out. Now the rule is, the most interesting part of the game is, one electron of metal atom will get one packet of energy, right? This is the rule to play this game. What is it? So I have this metal surface, I have atoms in the metal surface, and atoms has electrons. So if I want to take these electrons out of this metal surface, I need to supply energy. And how I am supplying energy? In the form of radiation. This radiation has packets of energy. So now the rule is, one electron will get only one packet. The rule is, one electron will get only one packet of the radiation. If the energy in that packet is sufficient for that electron to come out, it will come out. Else it will not. Rule is, one electron, one packet, whatever may be the energy, right? Yes. So suppose I am distributing chocolates in the class, right? Yes, but the rule is one student will get only one chocolate. Not more than that, not less than that. One student, one chocolate. So I am distributing chocolate in the class. So your happiness will depend upon which chocolate I am distributing. I am distributing same chocolate to everyone, right? But the rule is one student, only one chocolate. Not more than that, not less than that. Not 1.5 chocolate, no 2.5 chocolate. So one student, one chocolate. Now you will be happy if that chocolate is your favorite chocolate, it is the bigger one, right? Doesn't matter how many chocolates I am distributing, you are only getting one, na? What matters to you is which chocolate you are getting, right? The same is with the electron. So electron in the metal atom will get only one packet of this radiation. The happiness of electron will depend upon how much energy that one packet has. If that one quanta, one packet of energy has sufficient energy that is being required by this electron, then it will come out. If that energy is not sufficient, right, the electron will not come out. Yeps. Yes. Doesn't matter how many packets I am distributing. Electron is saying only I will get one packet. Doesn't matter, na? You are like falling 100 packets on metal surface or 1000 packets. I am only getting one packet, yaar. I'll be happy if the energy of that packet is sufficient. That will make me happy. That will satiate my hunger. Right? Yes. So suppose I'm incidenting a radiation and this electron is not coming out. What does that mean, guys? I am falling a radiation and the electrons are not coming out. What does that mean? That means the electrons are not happy. The one packet that they got from the radiation, and all the packets have, by the way, same energy in one radiation, right? So for a particular radiation, all the packets have one same energy. Yes, that means the energy in the packet is insufficient. That is not enough to take this electron out. But still I want. Please come out of the metal atom electrons, please. So I use my Maxwell brain. So as for Maxwell, fall more packet. Increase the number of packets in the radiation. So initially I was falling 100 packets. Now I have increased the number of packets, that is 150. Now I am falling 150 packets on the same metal with the same energy. Will the electron come out, guys? Will the electron come out? Now I am, no, see, I have increased the number of packets. Now I am putting 150 packets on this metal. Will the energy come out? No. The rule is one electron will get only one packet. Still that poor electron is getting the same one packet. Even if you are now distributing 150 packets, again electron will not come out. So Maxwell brain said so, and he was proven wrong because electrons didn't come out. That was one of the failure of Maxwell theory. He could not explain photoelectric effect. Yes. Now I want electron to come out of this metal. How I can do, guys? Use your scientist brain, use your Einstein brain. Use your Einstein brain. So use your Einstein brain. Now I want the electron to come out. It is not coming out. How can I use your Einstein brain? We use the Maxwell brain and we were proven wrong. Now use your Einstein brain, guys. Ma'am, we have to increase the energy of one packet. Electron will get one packet. Please increase the energy of the packet, na? Guys, how can I increase the energy of packet? Ma'am, E is directly proportional to nu, frequency. Increase the frequency of the radiation. If you increase the frequency of the radiation, the energy of one packet will automatically increase. Because the energy in one packet is directly proportional to nu as per Planck quantum theory. Okay, ting, 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 ting. Einstein brain works, and I increase the frequency of the radiation, and as soon as I increase the frequency of radiation, electrons start coming out. More I increase the frequency, more is the kinetic energy of the photoelectrons that are coming out. Yes, got it? That means when the electrons are not coming out, the frequency that I am giving is less than the threshold frequency. That is why the electrons are not coming out, right? So I have to increase the frequency, the energy of one packet, because electron will get one packet. Yes? Frequency increase means energy of packet increase, because energy of the packet, energy of quanta of the radiation is directly proportional to frequency. See, now light is dealing with atoms and electron, and it is behaving like a particle, packet, quanta nature. So whenever your light interacts with microscopic particle, its particle nature dominate. It behaves like it has a packet of a nature. So using the particle nature of light, Einstein G proved the photoelectric effect phenomena. Right? Until or unless the energy of one packet of the radiation is not sufficient, your electron will not come out. Yes. Got it? So if your metal is not showing the photoelectric effect with certain radiation, increase the frequency of the radiation, so that the frequency of the incident radiation becomes more than the threshold frequency of the metal. Got it? Yes. Done? This is explained by Einstein G, and he gave a beautiful, so I mostly show this meme. So whenever the light of frequency greater than the threshold frequency comes, the electron will come out. Yes, Aditri. Yes. If you give just equal to threshold, they will just come out. If you give extra, that will get converted to the maximum kinetic energy. Right? So the threshold energy is also known as work function. The threshold energy, E naught, right? See, that is also known as work function. E naught is known as work function, that is h nu naught, threshold energy, and we represented it by phi also. Work function is h nu naught. Right? Work function is the minimum energy required to remove the electron from metal atom, and different metals have different work functions. Got it, guys? Now Yash got confused in a very interesting point. Frequency means energy of one packet. More frequency of radiation means you are increasing the energy of one quanta, one packet of that radiation. And number of quanta means intensity of the radiation. Please listen carefully. If I'm saying I'm increasing the intensity of radiation means I'm increasing the number of quantas in the radiation. I'm throwing more quantas. If I say I'm increasing the frequency of radiation, that means I'm increasing the energy of one packet of that radiation. It has packets, each packet has equal energy. So increase in frequency means increasing the energy of packet of the radiation. Got it, guys? Yo or no? Do you get it? What do you mean by increase in frequency of radiation, or what do you mean by increase in intensity of radiation? Intensity of radiation means more packets, more quantas. Number of packets increases. Increasing the frequency means I am increasing the energy of that packet. Quanta is, Aditri, you joined late. You didn't watch the last session. Please do watch that. Energy packet. Planck quantum theory. Got it, guys? Yo. So this is photoelectric effect. And please see, if frequency is less than threshold, no electron ejected. If it is greater than, the electrons will get ejected out. The ejected electrons are known as photoelectrons. Yo. And using the Planck's quantum theory, Einstein G explained the photoelectric effect, and he got the Nobel Prize for the same. Yes. Yo. So explaining the photoelectric effect using Planck's quantum theory, he got the Nobel Prize in theoretical physics. Right? Physics Nobel Prize he totally deserved it, right? So he gave this equation. This is Einstein's equation also we call it. Einstein's equation. Let me. So what will happen? If this is the energy of incident radiation, the radiation that we are falling on the metal surface, some part of energy, that is threshold energy, will be used to take out that electron, right? The threshold energy is, for example, the threshold energy of that metal is 10 joule and I am falling 12 joule. That means 10 joule is used, is consumed taking the electron out. Yes. And then rest will get converted into the maximum kinetic energy of the electron, the photoelectron. If you gave extra energy, more extra energy you gave, more can be the maximum kinetic energy of that outgoing electron. See guys, Tejas ma'am, it is chemistry, and how he got the Nobel Prize in physics. Photoelectric effect is also there in physics, right? PE is also there in physics. And my dear lovely students, this atomic structure, again, see, in chemistry, atomic structure is the structure of atom is usually the very first chapter that we study in chemistry in class 11th. And the same chapter we studied in modern physics at the end of class 12th in physics. So basically, it's not chemistry or physics, it is science, right? Atomic structure of class 11th. You start your chemistry with structure of atom in class 11th, and you end with your physics of class 12th with the same, under the name of modern physics. Yes. In modern physics, you studied the same thing. Got it? So basically, everything is connected. It is science only. We are like making it a, making the differentiation, physics, chemistry, biology and all. So it is just the science. Enjoy the science. Don't put it into compartments. It is physics. I don't like chemistry. I don't like biology. I like physics. Don't put science in different compartments. Just enjoy it as a science. You'll have more fun, guys. It is a science, right? Yes, because when we put it into boxes now, we tend to be, partial. Oh, I don't like this subject, I like that subject, I don't like this and that, right? And we have so many preconceived notion about any subject. Like I usually come across, like I'm very sure that most of the chemistry teachers, they usually come across this misconception that ma'am, chemistry means ratta, chemistry means ratta. Oh, there are so many exceptions in the chemistry, ma'am. Like, so that is why I don't like chemistry, ma'am. Another exception. I'm sure many of you feel the same, right? Full of exception, full of ratta, ma'am, right? Because itna kuch yaad rakhna padta hai. We are supposed to remember so much. That is why we don't like this biology or whatever, chemistry and all that. But let me tell you, the exception in chemistry, what we call exceptions in chemistry, I always tell my students, they are not the exception, that is the limitation of our understanding. We couldn't go into that deep in science that can explain that phenomena. So because our level of understanding is not that much well that could explain this, that could, prove that fact. So we learn it as an exception. Because we are incapable of explaining or finding the reason behind it. So till the time we got the reason and a correct theory to explain that phenomena, till the time we take it as an exception. Yes. So guys, treat it as a science. I can definitely relate to, see, most of you, whenever I ask now, like whenever science student I ask which is your favorite, mostly say physics. Why physics? Have you ever tried to think why most of the science lovers, they enjoy the physics more? Have you ever thought of it? No, everything is logical. Science is logical. There's no science without logic. If I'm studying science, if I'm studying math, that has to be some logic behind it. Yes, most of the students, they love physics because it is for the simple reason. Logic is everywhere. Science, when there is a logic, right? It is just that we can relate with that thing, because in physics we study the natural phenomena, the macroscopic world, right? Rotation I can feel, gravitation I can feel. Most of the phenomena that we study, buoyancy and everything, that we can relate to because we can feel in our day-to-day life. And nobody of you have seen atom ever. Forget about electron. And I'm talking about electron. Nobody of you have ever seen electron, and will not be able to see, most of you, until unless you use that atomic microscope. So how can you relate with the chemistry most of the time? That is where the difference lies. It's not about the logic or the whatever you call it. It is just that whatever I can relate to, I can definitely understand it in a better sense. And if I have not seen anything, I'm just listening the, theories, the stories. Yes? So that is the reason. Try to think, try to change your perspective, guys. If you are studying science, so you have to treat it as a science, right? Don't put it into different compartment. I like this, I don't like that. Treat it as a science. Trust me, you will love it, right? And wherever there is an exception, now just remember, guys, wherever in your 10th, 11th, 12th, you're going to deal with so many exceptional cases in organic chemistry or in chemistry particularly. Whenever you write an exceptional case, don't feel it is an exceptional case. Whenever you write in your notebook, in your notes, that it is an exceptional case, don't treat it as an exceptional case. Right away then, there and then, tell yourself it's not exception, it is the limitation of our understanding. We are not able to decode this now. That is why I have to memorize it with as an exception. My limitation it is. Our limitation as a human it is. Maybe in future, our coming generation might not be, remembering it as an exception. They might have a better theory to explain why that happened. Yes? Got it, guys? Okay, so let's get back to our Einstein. So Einstein explained the photoelectric effect using the Planck quantum theory, using the particle nature of the light. And he gave this equation: the energy of incident radiation, that is equal to the threshold energy required to eject the electron, and the rest will get converted into the kinetic energy of the incident radiation, right? The photoelectrons, and this is known as Einstein's equation. Let me, E is equal to h nu, energy is equal to h nu. This is h nu naught, the threshold frequency, and kinetic energy is half mass of electron. Can anyone write the mass of electron in the chat box? V square, half mv square, right? Can any one of you, because the electrons are coming out, the photoelectrons, right? Okay, got it, guys? So this is it. So this is Einstein's photoelectric equation. Very, very, very important, guys. So the mass of electron is 9.1 into 10 to the power minus 31 kg, right, Aditri? So guys, now if you understood the photoelectric effect, right? So just let me know quickly whether the electron will come out or not. Depends upon what? The ejection of electron from the metal surface, whether the electrons will come out or not, that will depend upon the frequency of incident radiation. If the frequency of incident radiation is more than the threshold frequency of metal, the electron will come out with energy, right? That depends upon the frequency of incident radiation, which has quanta energy, right? Yes. And suppose if the frequency of the incident radiation is more than the threshold energy, of course the electron will come out with some kinetic energy. Yes. how many electrons will come out? So this condition is satisfied. Now the number of photoelectrons, how many photoelectrons will come out will depend upon how many electrons can come out with kinetic energy, because the energy of incident radiation is more than threshold. Now tell me, in that case, the number of photoelectrons, the electrons that will come out of metal, is equal to number of quantas in the radiation. Remember the rule, one electron, one quanta, and the energy of one quanta, one energy packet is sufficient. So more packets you fall, more electrons will come out, because the energy in one packet is sufficient for an electron to come out. Yes, so the number of electron, more is the number of quantas, that is more is the intensity. So more is the intensity of light. The more quantas you fall, you throw on the metal surface, more is the photoelectrons, more is the electrons that will come out of metal, provided this is only true if, until unless this condition is not satisfied, electron to nahi aayenge, they will not come out. Got it? Yes. Done? So if I ask you to plot a graph between incident frequency, right, and the kinetic energy of photoelectrons, incident energy and the kinetic energy of photoelectrons. So at least this is mu naught. That is the threshold energy. The electron will only come out if your frequency, incident frequency, is more than threshold, right? More is the incident energy, the frequency of incident radiation, than the threshold, more will be the kinetic energy. More extra energy you give than threshold, more will be the kinetic energy. Got it? Yes. Done. Yes, photoelectric, where metals are conductors. Metal can lose the electron easily. They have low ionization energies. The ionization energy, the energy required to remove electron from non-metal, is high. Right? So guys, more is the extra energy than the threshold energy. More can be the kinetic energy of the photoelectrons they are coming out. Yes? Okay, please watch it again, Rifat. Now the question, you can see the question here. The minimum energy necessary to overcome the attractive forces between the electron and the surface is this. This is the energy, that is the threshold energy. So basically, they are putting the question in another way. So this is the threshold energy, E naught. So let me, this value is given the E naught, the threshold energy. What will be the maximum kinetic energy of the ejected electron from silver metal, which has been, this is the wavelength, lambda naught. So basically, incident radiation, so this is not the lambda, incident, hc by lambda, right? Yes. So again, the Einstein equation, incident energy is equal to threshold energy plus maximum kinetic energy. So this is given to you, threshold energy. And how can you calculate this? Because E is equal to hc by lambda. You are given the wavelength. Please convert it into meters. So incident energy you have, threshold energy you have. The difference between the two will be the kinetic energy. Can you please tell me? Rifat, please watch the session again if you join in between. I'm very sure you get it. If still you don't get it, put it in the comment section, my dear. So using this Einstein's equation, we can solve this question, guys. Right? You can see here, directly putting the value. Nothing else. Take care of the units, guys. Be very careful about the units. Now the next question. The threshold wavelength, lambda naught, mu naught or lambda naught, is given. The work function they are asking you. Work function means threshold energy. Let's see, E naught, that is the threshold energy, that is equal to h mu naught, that is the threshold frequency, and you know frequency I can write C by lambda. So lambda naught is given to me. Yes, please solve. Lambda naught is given to me here. Nanometer, please convert that into meters, SI unit, so that you can calculate E. Planck's constant, you know, c is the speed of light, right? I hope you all remember the speed of light is. SI units, please use lambda naught. What is given? 330 nanometers. That means you have to convert it into meters. Put the values. Planck's constant is the constant value, and let me know the answer to this question. Yes, the answer, please. I've given you the enough time. If you could solve, the answer is C. Very right. Those who gave C as the answer. Well done, guys. And now you have a homework question from the same Einstein's equation. Yes, so please take the screenshot, note the question, and you can write your answer to this question in the comment section of the video. Right? Yups. So please keep on following B2A series. Tuesdays are for chemistry, Thursdays are for physics, and Saturdays are for biology. If you want to crack NSEJS, you want to be NSEJS qualifier and want to be among top 300 science lovers in India, follow the series, right, guys? So I hope you know we are already running the NSEJS prime batch targeting NSEJS 2025. Those who want to be the part of this regular batch where we are having live sessions, full mentorship, regular testing along with the content that we are going to provide in the batch, full-fledged preparation for NSEJS, right? So the batch price is 6,999 using the code NPR Pro. The link is in the description box. I'm there in the batch to explore the world of chemistry with you guys. Yes, so be there. And if this is your target, you want to be junior science Olympiad qualifier, you want to have the tag with you, if you want to be a certified science lover by cracking the most prestigious exam, right? So be a part of the batch. Yes, because batch gives you a discipline, a sincerity, a regularity, right? So that is the benefit of batch. You can solve question, you can ask your doubts regularly, right? There is a two-way interaction in the batch. Yes. So bye, take care, God bless you all. Keep learning, keep growing. पढ़ते रहो, बढ़ते रहो, मचाते रहो, देश को गोल्ड जिताते रहो. See you in the another session of the same series, right? Till then, bye, take care, God bless you all. And do not forget to join the Telegram group of NSEJS Cult. तो अगर आप अभी NSEJS 2025 एस्पिरेंट हो एंड अपने जैसे बच्चों से इंटरेक्ट करना चाहते हो और देखना चाहते हो कि कौन कैसी तैयारी कर रहा है देश के किस कोने में, तो आपको इस वीडियो के डिस्क्रिप्शन बॉक्स में एक टेलीग्राम ग्रुप वेदांतु NSEJS 2025 अपडेट्स का एक टेलीग्राम ग्रुप का लिंक मिलेगा. प्लीज डू नॉट फॉरगेट टू ज्वाइन दैट ग्रुप. राइट, बाय, टेक केयर, गॉड ब्लेस यू ऑल. हाँ, चलो बाय, टेक केयर. अगर कुछ रह गया है, डू राइट इन द कमेंट सेक्शन, आई विल आंसर. राइट, बाय.